Because the line segment that we're looking at is much smaller than the distance that is traveled by the current, we can say that the magnetic field is given by mu naught over 4 pi the current I dl crossed with r hat over r squared. Again, r squared is the distance from the point that we want. And notice that for point 1, the distance to that is r hat is going to be in the j direction, positive j direction, where for point B, r hat is 30 degrees above minus I hat. So it has a two-dimensional space there, vector representing it. So now we can say, and because the current is moving to the left, we can say that dl is always going to be minus dl I hat. It's moving always in the same direction to the left. So if we look at this equation and we look at point 1, then we have, like we said, r hat is j hat, and if we say b vector equals mu naught over 4 pi I dl, I'm going to make this a capital I because we have I hat here, minus I hat crossed with j hat all over r squared. This is going to give us mu naught dl I over 4 pi r squared, and this is going to give us a k hat direction. Minus I crossed with j will give us a k hat direction. Minus k hat direction. So we can rewrite this as minus mu naught I dl over 4 pi r squared k hat. For point B, P2 I mean, in this case r hat is going to be minus cosine of 30 degrees I hat plus sine 30 degrees j hat, right? It's a unit vector pointing at 30 degrees from the x direction. So this means that the magnetic field is going to be mu naught I dl times minus I hat over 4 pi r squared, and this is crossed with minus cosine 30 degrees I hat plus sine 30 degrees j hat. And we know that when we cross an I hat with an I hat, it disappears, so we only get a contribution from the j hat, and this gives us mu naught I dl sine 30 degrees over 4 pi r squared, minus I times a j we already know is a minus k hat, so this again equals minus mu naught I dl sine of 30 degrees all over 4 pi r squared k hat. Now if we plug in the values, so at P1 we have mu naught, which is 10 to the minus 7th. Mu naught over 4 pi is 10 to the minus 7th Tesla meter per amp times the current, which is 125 amps, times the distance dl, which is 1.0 times 10 to the minus 2 meters over 1.2 meters, quantity squared, equals b vector, all of this in the k hat direction. This gives us a magnitude of minus, there's a minus out here, minus 8.7 times 10 to the minus 8 Tesla k hat. And then similarly, if we plug in the values for P2, B hat equals again 4 pi divided into mu naught will give us 10 to the minus 7th Tesla meter per amp times 125 amps times the distance dl, which is 1.0 times 10 to the minus 2 meters times sine of 30 all over 1.2 meters, quantity squared, all in the k hat direction, which equals, again, forgot the minus, negative 4.3 times 10 to the minus 8 Tesla k hat. So our two results are written in the box over there.